Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. In a period, the first ionization enthalpy of the element at extreme left and the negative electron gain enthalpy of the extreme right element except noble gases are respectively. Okay. So the chapters involved is classification of elements and periodicity in properties. So ionization energy is the minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom so as to convert it into a gaseous cation. Okay, important. Minimum amount of energy required to remove most loosely bound electron from isolated gaseous atom to convert it into gaseous cation. Okay, with respect to diagram, let's say this is our atom, this is our nucleus. So let's say this is the most loosely bound electron. So how much energy I have to give to this electron so that it goes out from the atom and the atom converts into a gaseous cation. Okay, so ionization energy is represented by delta IH, and the process is represented as this. So you can see we start with a gaseous atom and then we give energy, ionization energy or ionization enthalpy to this gaseous atom, and then it loses one electron, and in that process it becomes or it converts into a gaseous cation. Okay, there are two important factors governing ionization energy. The first one is nuclear charge. Okay, and ionization energy or enthalpy increases with increase in nuclear charge. Very important. Okay, that's because as nuclear charge increases, or you can say as the number of protons increases, electrons of outer shell are more firmly or tightly held by the nucleus, and therefore greater energy is required to pull out an electron from the atom. Very important. As nuclear charge increases, electrons of outer shell more firmly held by nucleus. So therefore, more energy required to pull an electron out from the atom. Okay, and the second factor is atomic size or radius. So ionization enthalpy or ionization energy decreases as atomic size increases, because as the distance of outer electron from the nucleus increases, so let's say this is our nucleus. So initially, let's say the electron was here, and then we are comparing it with another atom whose outermost electron is here. It has a bigger size. Okay, so as the distance of outer electron from the nucleus increases, attractive force on outer electron decreases. So this electron experience more attractive force from the nucleus compared to this electron. So therefore the outer electrons are held less firmly. So this is held less firmly compared to this guy, and hence even a lesser amount of energy is required to knock this guy out compared to this guy. Okay, so in general, as we move from left to right in a period, ionization energy or ionization enthalpy increases because when we go from left to right in a period, the nuclear charge increases as the atomic number is increasing, and also the size decreases. Okay, so both of these factors are resulting into this. Okay. So therefore, in each period, a group 1 element, that is a alkali metal, is present at the extreme left, and they have the lowest first ionization enthalpy value in a period. For example, in the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So the value of the first ionization enthalpy of lithium is 520, 899, 801, 1086, 1402, 1314, 1681, 2080. So you can see in the second period, lithium has the lowest first ionization value, and in general, it increases. Although there are some anomalies, for example, this is one, this is another. Okay, so I will write this down that in each period, element at extreme left, which is a alkali metal or a group 1 metal, has lowest first ionization energy. Now coming to electron gain enthalpy. So electron gain enthalpy of an element is the energy released. It can be absorbed also for few elements when a neutral isolated gaseous atom accepts an electron to form the gaseous negative ion, or you can say the anion. Okay, so electron gain enthalpy is the energy released, sometimes absorbed, when a metal, sorry, when a neutral isolated gaseous atom accepts an extra electron to form gaseous anion. Okay, so the process is represented as, so you can see we start with a gaseous atom and we are adding one electron, and in that process it becomes a gaseous anion. Okay, or we can also say that the electron gain enthalpy of an element is a measure of the strength with which an extra electron is bound to it. Okay, there are two important factors governing electron gain enthalpy. The first one is nuclear charge. So as nuclear charge increases, the force of attraction between nucleus and the incoming electron increases. So let's say that X has a very high nuclear charge. So the force of attraction between the nucleus of X and the incoming electron, that is very high. So therefore, electron gain enthalpy will become very, very negative, or you can say it will become more negative. So therefore, as nuclear charge increases, the force of attraction between nucleus and incoming electron increases. So therefore, electron gain enthalpy becomes more negative, or you can say more amount of energy is released. The second factor is size, or atomic size. So as size increases, the distance between nucleus and the last shell which receives the incoming electron increases. Right? For example, let's say you have the nucleus here, and this is the first atom, and let's say you have another atom and it is a bit bigger in size. So as the size increases, the distance between nucleus and the last shell which receives the incoming electron increases. So here this was the distance. Now for a bigger atom, this is the distance. Okay, therefore the force of attraction between nucleus and incoming electron decreases. So here the electron that you are adding will receive more attraction. Here the electron that you are adding, since it is far away from the nucleus, will receive less attraction. or you can say the force of attraction between nucleus and incoming electron decreases. So therefore, electron gain enthalpy becomes less negative. So therefore, as size increases, delta EGH becomes less negative. Okay. So in general, delta EGH, that is the electron gain enthalpy, become more and more negative from left to right in a period till the 17th group, or you can say the halogens, because from left to right in a period, when we go from left to right in a period, the size increases, sorry, the size decreases and nuclear charge increases. Okay, so because of these two factors, the electron gain enthalpy becomes more and more negative. Okay, and halogens, that is group 17, fluorine, chlorine, bromine, iodine, so those guys have the most negative electron gain enthalpy in a period. Very important. Most negative delta EGH in a period, because their valence shell configuration is ns2np5. Okay, they just need one electron to acquire the noble gas configuration, so they can accept one electron easily to become ns2np6. So therefore they have the most negative electron gain enthalpy. Okay, and the electron gain enthalpy of noble gases are positive, that is delta EGH of noble gases are positive. Okay, because they have completely filled subshells and the next electron has to be placed in an orbital of the next higher shell. Okay, so therefore energy has to be supplied for that case, and also you are disturbing a very stable configuration. Okay, so with respect to data, for example, in the second period, I have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. For lithium, the value is -60, beryllium it is +66, -83, -122, +31, -141, -328, and +116. So you can see there is no regular pattern, obviously, but the most negative electron gain enthalpy is for the group 17th guy, fluorine, that is -328. Okay, and you can see the noble gas neon has +116. Okay, so in a period, the first ionization energy of the element at extreme left, that is group 1, is the lowest. Alkali metals have the lowest ionization energy, therefore they are very good metals, they can easily lose their electrons, and the negative electron gain enthalpy of the extreme right element, except the noble gas, that is we are talking about halogens, group 17 is the highest. That's why they are very, very electronegative. They can easily accept one electron to form, the fluoride, chloride, bromide, or iodide ions and complete their octet. Okay, so therefore the answer will be lowest and highest. Okay, thank you.